Today I will start the class with the same topic of thrust, which we were talking last time. So please, everybody, be ready for the class. So during this time, let me ask a question. Okay, knowledge questions. So voluntarily, anyone can give the answer. The question is very simple, dear students. What is upthrust? What is upthrust? So you can unmute your mic and respond to answer. I repeat, the question is, what is upthrust? That means you have to say the
Buoyancy.
definition of, please, yes.
Sir, upthrust is the force given exerted by any fluid.
Yes, excellent. Thank you so much. Yes, it is the force exerted by the liquid on an immersed body. And the direction of upthrust is
Upwards.
upward. Very good. Yes, this is the force that acts against the gravity. So it is an upward force. So by name, so we can simply understand the meaning of upthrust. Okay, then another questions, very simple question. Can anyone tell me the SI unit of upthrust?
Newton.
Yeah, it is Newton. Very good. Yes, Newton it is, right? Okay, and the third questions I have here. So in the beginning of today's class, uh, theoretical proof of Archimedes principle. Okay, there we get. Or I'm asking you to just simply say the formula or equation for finding the upthrust given by the liquid.
Sir,
Last
V rho
time,
V.
yeah, it is U equal
V rho
V
G.
dg. Yes, very good.
V rho
Yes,
G.
yes, yes. Rho. I said D. The D or rho stands for density of liquid. Very good. Thank you so much. So, dear students, are ready for the class? I can see only few students, only 16. So, where are others? Anyway, let's start. Okay, they will join. So, in their time, today we are going to read about upthrust. Then we'll connect to Archimedes principle of thrust, factors affecting upthrust, and the method to measure upthrust of liquid. Let's begin the class with factors affecting upthrust. So you can see there's strange. We have four factors that affect the upthrust of the liquid, and those four factors are: first is volume of the submerged part of the body, which is also the volume of liquid displaced, okay, by the immersed body. Since volume of submerged portion of the body is equal to the volume of displaced liquid. A second factor is the density of the fluid, or you can say liquid. Third, you can see acceleration due to gravity. And at last, number four, temperature. So among these four factors, upthrust is directly proportional to the three first factors, means volume of displaced liquid, density, and acceleration due to gravity. Whereas the last factor, okay, temperature, upthrust is inversely proportional. With the increase in temperature of the liquid, upthrust goes on decreasing. Whereas if the volume of displaced liquid increases, okay, that increase upthrust too. And with the increasing in density of liquid, upthrust in turn increases. And obviously, increase in acceleration due to gravity obviously increase upthrust. So you can see the figure over there, distance on your screen. So that the right side, okay, of this vessel, if you observe there carefully, you can see a body is immersed completely. So this is, you know, fully immersed. So in second figure over here, you can see a body is fully immersed. And in this case, the total volume, okay, of the body which is immersed inside the liquid is equal to the volume of displaced liquid is responsible for producing upthrust in this liquid. So here in this case, when a body is fully immersed inside the liquid, the total volume of the object is the responsible factor for producing upthrust. Whereas if you go to the left, that is figure, so where we can see the object is immersed partially. So you can see over there half of the object or body is outside the liquid and only half of the part is inside the liquid. So this below, this beneath part, which is inside the liquid is immersed part. So we can say this is partially immersed. And in this case, this portion which is immersed partially inside the liquid is responsible for producing upthrust. So how is a body immersed inside the liquid? And according to that, its portion submerged or immersed inside the liquid is the factor that produces upthrust of the liquid. And second factor is their density of the liquid strength. Okay, here if I consider, okay, a vessel that filled with pure water, water only, and second vessel I have here the strength, so which is filled with the salt solution. Salt solution means mixture of salt and water. And if you try to compare the density between these two liquids, obviously the second vessel filled with salt solution has more density. Means the salt water, okay, bears more upthrust than the pure water because of its more density. So with the increase in density, upthrust of the liquid also increases. So in this case, salt solution has more density than the pure water. So by which the salt solution gives more upthrust. And second, the third factor is their acceleration due to gravity. Let us consider taking the same liquid and the same object immersed inside the liquid. Now, if we take that vessel containing the liquid, okay, with immersed body inside it, first at Kathmandu, right? And then after taking the vessel with the same liquid and same immersed body to Biratnagar. So where do you think that the liquid exerts more of thrust? Obviously at Biratnagar, because with the change in place, if there is a change in acceleration due to gravity, upthrust also changes. And in between Kathmandu and Biratnagar, in Biratnagar, we find the value of small g, means acceleration due to gravity is more, and due to which the same liquid exerts more of thrust at Biratnagar. And finally, the last factor is temperature. So when we increase the temperature, upthrust of the liquid decreases. It is because when we increase the temperature, means that is the effect of it that causes expansion. Expansion of a substance means that increase the volume. And when there is increase in volume with a fixed mass, definitely it brings the change in density. That is a decrease the density. And with a decrease in density, yes, upthrust decreases. So increasing temperature always decreases upthrust, because upthrust and temperature are inversely proportional. So did you understand? So the resistance are there. I hope you are listening to me properly. Okay, now let's know another, okay, part of the chapter. So experimentally, how can we measure or find the upthrust of a liquid? So to know the upthrust of any given liquid, so when a certain or particular object is immersed in it, then we can carry out some activity or experiment. So where we need measuring device called upthrust, sorry, spring balance. The measuring that device is spring balance. So by which we can measure or find out the upthrust given by the liquid. For these students, first of all, you have to measure the weight of our body, so which is going to be immersed inside the liquid, so that we can measure the upthrust of a liquid. Should be measured in the year. Meanwhile, let me tell you, dear students. So when we have different media, okay, for measuring the weight, then always, in case of the earth, we find maximum weight in the year. That means weight for any body, any object is the real weight in the year. So you have three media, for example, right now. Okay, one is air, another water only. The next medium is a solid solution. So among these three media, so if you measure the weight of object in air, so that always gives the maximum value of weight, because air has less of thrust, and due to which there is the more effect of gravity. Gravity is the force which is responsible for the weight of an object, right? So first of all, measure the weight, okay, of the taken body in the year. And here W1, okay, is used as a symbol or as denotation for weight in year. So which is the real weight. So after finding the weight of the body in the year, now try to immerse the same body inside the liquid or water or any liquid, which upthrust you are going to measure. Now, when we immerse the same body that's suspended in spring balance inside the liquid, there you find the decrease in weight. That means when a body is immersed, either partially or wholly, inside the liquid, a body loses weight. That means there is the loss of weight of body inside the liquid. It is because of the force that acts opposite to gravity. That force acts in upward direction, and that force is upthrust. Means that we find the new weight, okay, of the same body when immersed inside the liquid, which is less than the weight in the air, and this weight is called apparent weight. So weight in air is real weight, right? This is W1. And weight in liquid, this is apparent weight, which is denoted by W2. So I have been telling that weight of a body is always maximum in the air. Whenever that body is taken to, okay, any liquid, then we find there is a loss of weight due to the upthrust given by the liquid. And here the students, the concept is there. So how much weight a body loses when it is immersed inside the liquid, that weight lost by the body is always equal to the upthrust, right? That means W1 minus W2 is equal to upthrust. The W1 minus W2 is, it is weight lost by a body in the liquid. Understood? For example, okay, if I say when we measure weight of that body in the air, and that is found equals to, let's say, 60 Newton, right? And the same body is immersed inside the liquid. At the time the weight is reduced or decreases. For example, in the liquid, the spring balance shows the weight of same body, that is equal to 40 Newton. And once we calculate the difference between these two weight, 60 minus 40, the answer we got 20 Newton is the weight lost by the body in the liquid and upthrust as well. Upthrust as well. So experimentally, so with the help of spring balance, so we can measure the upthrust of a liquid. And the equations to find the upthrust of a liquid by taking spring balance experimentally is weight in air minus weight in liquid. Means a real weight minus apparent weight. The difference between real weight and apparent weight always gives upthrust exerted by the liquid on an immersed body. बुझ्यो क्लास 10? बुझ्यो है? सुन्दैछौ नि सबैजनाले? Okay, then let's go to another slide. This is a short review on upthrust. So already we get to know the meaning of thrust, which is the resultant upward force. So exerted by the liquid when the body is partially or wholly immersed inside that liquid, right? So the ship is designed in a such a way that so the ship can experience lot of upthrust by the water, so it can float. And some points so regarding upthrust, so you can understand or you can see the figure. Here the first figure, okay, is showing the property of a body when it is immersed in the liquid, and this property is called floating. Okay, thus the first figure, you can see the body is floating, so with some portion inside the liquid. And then in the second figure you can see another property is called sinking. So what is the condition of weight of a body and upthrust during floating, and what is the condition, okay, between upthrust and weight during sinking? Is that students, in case of floating for a body, upthrust is always equal to weight of that body. That is real weight, not weight inside the liquid, the real weight that we have measured in the year. So what is the real weight of a body? That means weight of a body in the year. So when it becomes equal to the upthrust given by the liquid to it, then always a body floats in the liquid. For example, the real weight of a body is 70 Newton. So when that body is immersed in the liquid, if it experiences 70 Newton of thrust from the liquid, then that body is found floating on the liquid. And in the case when upthrust is less, okay, when upthrust becomes smaller than weight of a body, a 70 Newton is the real weight of body. Once we immerse that body inside the liquid, so if it experiences only 30 Newton of thrust, means upthrust is smaller than the real weight of body, then definitely the body sinks in liquid. Okay, so upthrust less than weight sinking, and upthrust equal to the weight of body, that is floating. And when there is far, that upthrust more than the weight of a body, and even the body that is floats, okay, that means it shows the movement, it shows the motion. Okay, later on I will show another example that we will understand clearly. Up to here, any doubt, students, any confusion? यहाँसम्म नबुझेको केही कुरा छ त है? अहिलेसम्म हामीले डिस्कस गरेको टपिक भनेको फर्स्ट अफ अल इज फ्याक्टर्स एफेक्टिङ अपथ्रस्ट, then we discuss the method to find the upthrust of a liquid by taking spring balance. And thirdly, we came to know that, right, yes, that the upthrust is equal to weight. So in case of floating, and upthrust is smaller than weight of body, so when it is sinking. So you can see here, upthrust is also called buoyant force. Please remember this. Okay, the word buoyant force, okay, it means upthrust. So when buoyant force is equal to weight, okay, the length of arrow shows both the forces are equal. So weight of a body is equal to buoyant force, means upthrust, then floating, right? When buoyant force is smaller or less than weight, so the length of weight is more than the length of buoyant force, means here the value of weight of a body is greater than the value of upthrust at the time a body sinks. Got it? Okay, then let's get connected to the measure, okay, part that slowly will come. That measure part is Archimedes principle. Before that, let's understand one understanding level of question. Okay, this is the question of understanding level. You can see the question on your screen. The question is like this, friends. When a bucket full of water is pulled up, okay, you are drawing water from the well, and in which condition, either inside or outside the water, so we feel easier to lift or draw water from the well. The first question is there, in which condition, either inside or outside, that we feel easier to lift up, and the tail question is the why. So can anyone give the answer, guess the answer? So where do we, okay, feel easier to lift the bucket of water? So either inside the water or outside. Yes, good. Thank you so much. Excellent. Very good. Inside. Yes, we feel easier to lift a bucket of water inside the water. Then what is the reason behind that? What is the cause? So what makes, okay, so that we feel easier or easily we can lift the bucket of water until it is inside the water.
So
The
buoyancy.
cause is, yes, buoyancy. Very good. Yes, excellent. So comparatively, water exerts more buoyancy or buoyant force of thrust than the air. So we feel easier to lift the bucket of water until it is inside the water due to the upthrust exerted by water. So when any liquid so gives upthrust to the immersed body, to the body which is inside the liquid, so it affects to reduce or decrease the weight of the body. So because of upthrust, of the liquid given, a body always loses its weight, okay, until it is inside the liquid. And due to loss of weight, okay, by the upthrust, and easily we can lift by applying less effort. So whenever we have to apply less force or less effort, yeah, okay, okay, yeah, there is. Don't worry, please. Okay, liquid exhausts upthrust from all, let's say, thrust from all direction. There is down thrust also, there is upthrust also, there is side thrust also. But the resultant, thrust given in upward direction becomes more than the, down thrust. So we talk only about upthrust. So are you listening, Ankit? The force is given by the liquid in all direction. And since the force given by the liquid in upward direction is more, that is the net force, okay, the effect of the force is seen on an immersed body, and due to which we only talk about the upthrust. So we will discuss that in a theoretical proof of Archimedes principle. Okay, so why don't we talk about down thrust? So why there is upthrust, you know? So we will see that in a theoretical proof of Archimedes principle. Just be patient. We'll come soon there. Now after this, so the major part is strength. Okay, you are so familiar with the great mathematician Archimedes, and there is an interesting moment. You know that moment? That is a eureka moment. So the meaning of eureka is I found it, I got it. One day when the great scientist, a mathematician, physicist, whatever you say, philosopher, so he was about to take a bath, and as he tried to go inside the bathtub, and he found some effect or let's say change in the water. Okay, at the instant, at the moment, he okay got an idea with the reason. So why does a body float on liquid, or why does a body sink? That means the reason behind floating and sinking of a body, okay, inside the liquid. So is that idea he found at that instant. So just without taking the bath, and he went outside, he ran outside, okay, on the road saying eureka and eureka. That eureka means I got it, I got it, I got it. That moment is called eureka moment. And at that moment, eureka moment, Archimedes gave a principle, which is the law of nature. So okay, in the nature, this activity, this effect, okay, this principle already occurs, but he, the scientist or mathematician who gave this happen in the nature. At the time, he was there, okay, to find the purity of gold. So whether the gold is pure or not, okay, with the help of density, okay, and by immersing inside the liquid, we can easily find. Just like we check the purity of milk. Okay, there is one device, lactometer, and lactometer is used to measure density of milk, so and find the purity of milk. So if shows the real density, and obviously that milk is pure. So whenever the lactometer indicates the density more than the original milk, then easily we can find that the in milk the powder or solid substance is mixed. And if we find the density of milk less than this real density, then we can easily guess that the water, so amount of water is mixed inside the milk. So the density of substance, okay, can be easily read or understood by immersing inside the liquid. Nowadays we have many devices called hydrometer and lactometer. Otherwise, at the time, okay, Archimedes propounded the principle well known as Archimedes principle. And the major term or word, so in this principle is upthrust. So it states, Archimedes principle states that when a body is partially or wholly, okay, some portion inside the liquid is partially, the whole body is inside the liquid wholly. So when the body is partially or wholly immersed in a liquid, and this body experiences, okay, an upthrust, means the immersed body receives a force, okay, which pushes that object, that body upward. So that is called upthrust, and that upthrust mathematically is always equal to the weight of liquid displaced, right? And that weight of liquid displaced is also equal to the weight lost by a body. Right? So when we immerse the body inside the liquid at the time, okay, if this body displaces, for example, 5 Newton of liquid, at the time we have to understand that, so 5 Newton is the upthrust, so received by this body, okay, from the liquid. बुझ्दै छ है? Okay, if any object or any body when immersed partially or fully, always it gets an upward force called upthrust from the liquid, and that force called upthrust is equal to the weight of liquid displaced by it. Right? So how much liquid here in the small beaker? So we get, for example, let's say 10 Newton. That means this is the liquid, or let's say this is the water, okay, displaced. So when this object is immersed inside the liquid, and if the weight of this liquid, which is displaced by this body, is 10 Newton, and obviously, okay, we are sure that the upthrust gained by this body is also 10 Newton. So mathematically, upthrust U equal weight of liquid displaced, okay, and also equal to weight or lost by the body. So this is the, that is a relation given by Archimedes principle. And following this principle, so nowadays we have many devices, okay, or let's say many instruments that we use in our daily life. So there are many applications we can find of Archimedes principle. So in our daily life, upthrust is equal to weight of liquid displaced. Please remember this one. Okay, the main, that the theme or principle of Archimedes principle mathematically is U equal weight of liquid displaced. Got it? Okay. Then students, I request all the students to be ready with copy and pen. So I hope you already have copy and pen. Now we are going to write in the copy. Okay, this let's say derivation, okay, or let's say this proof shows that, dear students, so Archimedes principle holds true. That means this is the law that really occurs in the nature. So we can easily prove mathematically whether the Archimedes principle really works, okay, in the nature or not. So theoretical proof of Archimedes principle. Please note down in your copy in exam. So you will be asked for 2 marks, okay, to prove this one. That is the formula for upthrust. U equal BdG. So you will be asked, okay, in the exam, asking so that of U equal BdG, where the symbols have their usual meanings. And there is a theoretical proof of Archimedes gives the formula for upthrust, and which also proves that Archimedes principle is true. Okay, it holds true naturally. For this strange, the first step, so we have to write in our copies to draw a figure. Okay, in the figure that you can see a beaker. This is the beaker, right? First draw a beaker. So with pencil you can, and fill the beaker, or let's say vessel, container, tumbler, whatever you say, with water, or you can say liquid. Okay, in general, let's say liquid. That means let's take a beaker filled with liquid, and the density of that liquid is D. Or we have another symbol that is called rho. Okay, this rho, it is just like Nepali no, and this symbol rho is for density of liquid. So let's take a beaker filled with a liquid of density D. Then after this strands, okay, we have taken a body which is a cylindrical in shape. Okay, shape doesn't matter, but right now here, so for this activity we have taken a cylindrical body. Okay, a cylindrical body of cross-sectional area A. Okay, that is cross-sectional area A, capital A, and height of that body is h, small h. Means, okay, a cylindrical shape body of cross-sectional area A, cross-sectional area A, and height h is completely, means is fully immersed inside the liquid. Okay, so that the body can get, okay, force in this side also, means down also, up also, and in the sides also, means from all directions, so a body can experience force. Okay, for this, okay, it is considered as immersed completely inside the liquid. So up to here, so density of liquid is D, right? And the area of body is capital A, and height, that is small h, of the body. These strains we know, okay, liquid pressure, so is affected by the factors like density of liquid, height of liquid, and acceleration due to gravity. That means with the change in height of liquid column, liquid pressure changes. And whenever we are there to measure height of liquid column, depth of liquid column, okay, we always measure from the free surface, okay, from top. So in case of liquid column, the height or depth is measured from the free surface, okay, not from down. Right? And from the surface. Let's consider there, okay, height from the free surface up to the upper face of the cylindrical body. Okay, this upper face is H1. H1 is the height, okay, of liquid column from free surface up to the upper face of a cylindrical body. And next height there is class 10. So I hope you are listening to me properly. S2. S2 is the height of liquid column from free surface up to lower surface of the cylindrical body. Okay, the real height of a body is H, but the height of liquid columns at different faces of the body are H1 and S2 in upper and lower faces respectively. You understand? Because we are going to just see that how much pressure is exerted on the upper face, okay, and the lower face. So for this, we have taken height of liquid column up to upper face and up to lower face. S1, okay, for the height up to upper face, and S2 for the height of liquid column up to lower face. And if you see here, okay, from free surface to lower face, height is S2, and free surface to upper face is H1, means S2 minus H1 is always H. Okay, so that means the height of cylindrical body S is also the difference of height S2 and height S1. So which is given here also. Okay, now let's move ahead. Okay, let's move on to the process. That now how are we going to, okay, find the formula of upthrust, that is U equal VdG, or to prove Archimedes principle theoretically. For the strains, let's write the pressure, okay, pressure on upper face. Now let me tell you, meanwhile strains, the pressure exerted by liquid, okay, from this side, let's say from left side and the right side, okay, they are opposite and equal. So they are opposite in directions and equal in magnitude because they are of the same level. They are at the same level, same height here. So why? The resultant pressure, or let's say force, okay, from both sides is 0. Got it? So due to the equal pressure given by the liquid on either sides of the cylindric body and opposite, they get cancelled. So the resultant pressure, or let's say resultant force from the side is 0. But so if you see the pressure exerted or given by the liquid on lower face and upper face, then you find the difference. They are not equal. Okay, they are not equal because of the different height. So S2 is more than S1. So once the height of liquid column is different, obviously the value of pressure is also different. Now, in lower phase, the pressure of liquid is obviously greater, and in upper phase, okay, the pressure given by the liquid is obviously, okay, less or smaller. And if we, okay, take that the P1 at the pressure at upper phase is given by what strength? F1 by A. Okay, this A is the area of this cylindrical body. Okay, and F1 is the force that acted in the upper phase. So when we have strength, the formula that replaced by the liquid pressure P1, then obviously we get what? That H1 dg. Get it? The liquid pressure is given by SdG, and pressure P1, okay, is exerted on the upper face, and up to upper face the height is H1. So here we have P1 is H1 dg, means force on the upper face is, you can see over there, okay, that's shown in blue color. Force on the upper face F1 is given as P1 into A, right? P1 into A, which is that is replaced by H1 dga. So are you understanding this part or not, students? बुझिरहेको छैन बुझाएको छ है फर्स्टमा चाहिँ हामीले ओरिजिनल वाट वी हेभ इज प्रेसर एट अप्पर फेस okay, P1 is equal to F1 upon A, means F1 is equal to P1 into A, and P1 is the pressure upper face, so which is given by H1 dga, and this is equation 1. Similarly, force on the lower face, that is F2, that is F2 equal P2 into A, and here P2 means pressure at lower face, and height of the lower face is S2, so the P2 is replaced by S2 dg, because d is same, that is the density of liquid, and g is at the same place, so acceleration due to gravity is same, and area of the cylindrical body is same. So